What's up, scholars? Today we're going to be talking about areas of triangles and quadrilaterals. We're going to get to use some formulas to do a bunch of questions about the areas of triangles and quadrilaterals. It's going to be a good time. All right, what's area? Well, it's how much space something takes up, right? So if we look at our area of a square, how much space does that take up? Well, you might think area is length times width, and you would be correct. In a square, we don't even have to work that hard because we know the length and the width are exactly the same thing. So our area is the side length, S, times the side length, S, because our length and our width are the exact same thing. So our area of a squared is just the side length squared. Pretty cool. Pretty wonderful. Area of a rectangle, also length times width. We can rename the length as the base and the width being the height, but it's going to be the base times the height. It's the same thing as length times width. Same thing. Area, base times height. Area of a parallelogram is actually going to have the same formula as the area of the rectangle. And let's see why. So here's our height. That's how tall that parallelogram is. Notice our height has a right angle to the base. That will always be true. That actually was true up here with our rectangle too. Our height had a right angle with the base. So imagine, if you will, in your mind that we take this triangle and we move it over to the other side. So that's also height. And we took that chunk of the base over here. So our bases would now be that segment. And we made this parallelogram into a rectangle. So that's why they have the same areas. Area, base times height. And then everybody's favorite, a triangle. Area of a triangle is 1/2 of the base times the height. And remember, the height is always perpendicular to the base. Got it? Got it. Great. Area congruence postulate. You might guess this, but if two polygons are congruent, then they have the exact same area. Two polygons are congruent, they have the exact same area. Which is why and how we explained the area of the parallelogram. We made this triangle move over there and made it equivalent to the rectangle. So we had the same formula. We made them, they would have the same area. Great. Area addition postulate. You know, math people, we're not super crazy with our words here. Area addition postulate. I'm probably going to be adding some areas. Yeah, the area of a region is the sum of the areas of the non-overlapping parts. Or if you have some shape, you know, it looks like this, and you could figure out the area of that triangle and the area of this rectangle, you would add them up, and then you'd have the area of that whole shape, right? Great. Wonderful. Wonderful, darling. All right, let's do some examples. Find the area of triangle ABC. Well, we know our area of triangle formula is 1/2 the base times the height. 1/2 BH. What are our bases and heights in this problem? 1/2. I see a right angle here. And I know that, because we talked about it up here, the height is perpendicular to the base. So we've got this height over here. Always with the coffee, you know. Height perpendicular to this base, even though it's not connected. That is the height. That's how tall that triangle is. Right? That's how tall that triangle is. So that's our height. And that height is perpendicular to, if we extended it, the base, which is 12 units long. So let's plug those in. 1/2 12 times 10. Well, what's 1/2 of 12? That's definitely 6. What's 6 times 10? That's 60. They didn't give us any units, so we're going to call it units. And its area, so it's squared. Area is 60 units squared. Wonderful. Find the base of a triangle that has an area of 48 square feet and a height of 3 feet. What's our formula for area of a triangle? 1/2 base times height. Very good. What is the area? Well, it's 48 square feet. So let's put 48 in for our area. 1/2. What's the base? I don't know. That's what I'm trying to find. What's the height? It's 3. So now let's solve this and get b by itself. Okay. I don't want to do fractiony stuff, and I'm not trying to pull my calculator out right now, so let's see what we can do. Trying to get b by itself. I know it's b right now is being multiplied by 1/2 and 3. So what I would do is divide both sides by 3, so I get rid of that 3, and I know 48 divided by 3 is 16. So 16 is 1/2 times the b. Now let's get rid of that fraction by multiplying by the denominator on both sides. 2 by 2. So that means 32 is the base, aka the base equals 32. 32 B, yeah. Cool. You guys are doing wonderful. All right, example number 3. Let's find the area of the parallelogram. What's our area of a parallelogram formula? Oh, that's right. It's base times height. A equals BH. What's the base here? The base is UT. That is 6. What's the height? I'm pretty sure that should have been marked with a right angle right here so that I know that that is exactly the height. So 3 is our height. Base is 6. Height is 3. 3 times 6 is 18. 18 units squared. That's the area of the parallelogram. Cool beans. All right. Number 4. Find the area of the figure below using the non-overlapping pieces. All right, so we got a rectangle, we got another rectangle, and we got a triangle. That's got some markings of congruence, meaning those are all equal to each other, so those are all 8. Those are all 8. So we need to find the area of this rectangle, the area of this triangle, the area of this big rectangle. Area of this guy, base times height. Area of this guy, base times height. Area of this guy, 1/2 base times height. We got a base that's 12, got a height that's 8. Base and height are the same. I wonder what kind of triangle that is. Oh, it's an isosceles triangle. And the rectangle's got a height of 10 and a base of 12 plus 7 plus 8. Leaving this as an exercise to the reader for you to figure out the area of these 3 things and add them up. Ooh, yeah. Okay, cool. Okay, cool. We got a couple more things that we can find the areas of, like trapezoids and kites and rhombi. This says the area of a trapezoid is 1/2. The area of a trapezoid is 1/2 the product of the height and the sum of the bases. 1/2 the height and the sum of the bases. Remember, your trapezoid has 2 bases. So you would add up the lengths of the bases, multiply that by the height, multiply that by 2, or divide by 2. Multiplying by 1/2 and dividing by 2 are the same thing. It's the same thing, man. Area of a kite and of a rhombus. Ooh, cool beans. The area of a kite and a rhombus is 1/2 the product of the lengths of the diagonals. So let's call this D1, diagonal 1. Let's call this D2, diagonal 2. Area is 1/2 the product of D1 and D2. Oh, I didn't put a box on that one. Let's put a box on it. Box it up. Yeah. All right, let's use our newfound knowledge. Oh, no, wait, first I want to show you why that's true. Why is that true? How do we find the area of a trapezoid? Where did that come from? Y'all remember what this is called? Oh, that's right. It's called the mid-segment. The mid-segment. And the mid-segment was halfway between the bases. So it was base 1 plus base 2 divided by 2. That was our mid-segment. And then we've still got the height going on here. Right? So just like we did on the beginning phases, if we chop this off at the edges of the mid-segment, and I put that triangle right here, and I put this triangle right here, voila! Now we have a rectangle that has a base that's as long as the mid-segment and the height. So it's basically the mid-segment times the height, and the mid-segment is 1/2 base. It's 1/2 of B1 plus B2. So we took basically the mid-segment times the height. That's pretty clever. It's really very clever, actually. How about the area of a kite and a rhombus? Well, here I see there are 2 triangles. I got a triangle on the top. Beep, bop, bada, boop, boop, boop. And a triangle, oh, different color triangle on the bottom. But we know that those triangles are congruent. So if I found the area of this triangle and I multiplied it by 2, that'll be the area of the whole kite. So the area of this triangle is 1/2 the base times the height. 1/2 the base times the height. But then I'm multiplying that by 2. 1/2 the base times the height times 2. That's really this base times 1/2. So it came from the area of the 2 triangles. All right. Let's do an example. Here. I'm actually just going to write the formulas for you, and then you're going to do it. Because you got this. Oh man, I switched over to the different color pen. Weird. This is a trapezoid. We know the area of the trapezoid is 1/2 the height times the sum of the bases. What's our height? Well, it's perpendicular to a base, so that's our height. And then it doesn't really matter which one's the base 1 and base 2 because we're adding. You can add things in different orders, right? Like 2 plus 3, that's 5. But 3 plus 2 is 5. So you could add things whatever order you want. So let's call that B1 and B2. Good. Area of this kite, we just said the area of the kite is 1/2 the product of the diagonals. Let's call this guy D1, this guy D2. So D1 is 4, D2 is 8. Find your area and show me next time you come to class. I love you guys. You're doing wonderful. You're the best. Deuces.